Okay. So this is kind of a preparation phase. So that whole first piece was just sort of getting ready to run through the math and be successful. And so um what you do now is you're looking for the piece of information that that we can get going with. And so um, if you look right here, we've got two pieces of information about the octane, and the question mark is over the water. So you're going to want to start over here because you don't have your question mark. So the question mark's over here with the question mark's over here, and so we're going to want to start over here because we have more information about that piece. And so that is kind of a strategy to help you out. So what we're going to do is we're going to write out the 775 milliliters of the octane. So we're going to start with that volume because I'm going to show you that the volume is a great place to start because you have this. That's density, and see these milliliters and those milliliters, they're going to play nice together, and that's going to help us out. So it's going to help us convert into something we can use, which is grams. Okay, so let's start here. So I'm going to write out 775 milliliters of octane. So I'm going to write CHH18. All right. So then what we're going to do is we're going to use a conversion factor. So if you don't remember, a conversion factor is a multiplication sign and a line. And on the bottom of that, we're gonna put milliliters because we want milliliters to go away. So you see top and bottom. Okay, but now if you look, and here's the trick, look at density right there. Grams over milliliters. That's a perfect conversion factor because it has grams per milliliter. So it reads 0.7025 grams for every 1 milliliter. Well, that's a conversion factor, right? So I could say, well, go back to my problem and I could say, okay, well, I could put grams on top and milliliters on bottom. And if I'm using this, then there's 1 milliliter on the bottom, and there would be 0.7025 grams on top. So it's just an excellent conversion factor because if you look at your units, milliliters are on top and bottom as they're canceling. So that's perfect. Now we have grams. All right, well, grams, you did this a lot. You've converted grams into moles a lot, and so that's not difficult for us to do. So we can then say, okay, I want to get rid of my grams because they're on top. I want to go to moles, and I know that I can figure out how many grams are in a mole by using my periodic table and looking that up. So you're going to add that up, 8 carbons and 18 hydrogens. So let's go ahead and do that real quick in our calculator. So turn on your calculator, and then let's go over to our periodic table. And so here's carbon right here, 12.01. So let's go ahead in our calculator, 12.01 times 8. And then let's add that to the hydrogen. So the hydrogen right there, 1.01. So let's add that to, in parentheses, 1.01 times 18. There's a whole bunch of those. And then let's put that all together, and we should get a value. Okay, I got 114.26. 114.26. Oops. All right, let's put that here. And that's from the periodic table. So I didn't make that up. This is the new step. I'm going to use a different color for this because it is the critical step. And the critical step is called the mole ratio. And so the mole ratio is when you're going to convert from the chemical that you have to the chemical that you want. And so this idea of, okay, the chemical that I want is going to be on top, and the chemical that I already have is going to be on the bottom. See, I'm going to get rid of one and go to the other. And so now the mole ratio, though, is going to do this for our chemical. All right, so what we want over what we have. So let's go ahead and think about that. So I have the C8, I have this C8H18. So that's what I have. So I'm going to put mole of C8H18 on the bottom. Now I'm going to run a space here, and so I'm going to have to put more of this on the next line, but this is all technically one long problem, okay? So just because I'm going to run a space, it's going to be one long problem. So I'm putting this on the bottom so it'll cancel. And then the chemical we want is our question mark. Right here. Right there. Question mark, milliliters of water. So we're going to put that on top. So I'm going to put moles. Now I can't go right to milliliters. I can only go to moles. So this is the mole ratio. Moles of what you want. Maybe I should put that here. Moles of what you want over moles of what you have. So we want moles of water. Okay, now where do we get the number? Well, this is where we get the number. We get these numbers that go here and here. We're going to get those from our balanced equation. So here we go. I have 2 of those to 18 of those. So that's your ratio. It's a 2 to 18 ratio. So the water gets the 18 and the octane gets the 2. So there's no mystery here. I got them here and here. Whatever number was in front of the chemical is where I got those. All right. Now, that's called the mole ratio. And you could stop right now and be done if you wanted moles of water. Like if you wanted moles of water, then you could stop and you'd have the answer, right? So do we want moles of water? No. We actually need milliliters of water. So we got to do some more stuff. But if we look at our units, they're canceling. So we've got grams on top. It canceled the grams there. And these moles canceled. And look, that octane now canceled. So right now we have moles of water. If you stop right now, you get moles of water. But the problem didn't want moles of water. It wanted milliliters. So we're going to have to do another conversion factor. Notice 1, 2, 3. This is our 4th one. Now this is all be in one line, but I'm running out of space, so I'm going to have to put it down here on the bottom. So I'm going to put it here. So what I'm going to do now is I'm going to use the same trick that we used a minute ago. I'm going to use the density as a conversion factor. So I'm going to use this density, just like I did there. I'm going to use that again. And so the density I'm going to use now is going to be this one. But see, that has that nice unit of grams per milliliter. And that's going to be super helpful. So do we want milliliters or do we want grams? We want milliliters. And so what we're going to do is we're going to go from moles into something that's going to help us out here. Because see, this is grams per milliliter. So in order to convert, I need grams. Well, if I have moles, I got moles of water, I can get grams of water. If I get grams of water, I can use density to get milliliters. So what we're going to do is take moles into grams. Now we've done this, so this is nothing new. So we want grams, so grams are on top. Oops, that didn't work. Grams are on top. We're going to get rid of moles. Moles are on the bottom. Moles get a 1. Grams are what water weighs. So you go to your periodic table, add up your hydrogen, and your oxygen. You're going to get 18.02. And that's from oxygen 1 and then 2 hydrogens. Now, see, we have grams. You're going to have moles cancel. And now we're going to go ahead and use density as a conversion factor because it has this very nice conversion into milliliters for us. So that's 0.9982 grams for every 1 milliliter. So I'm going to get rid of the grams. I'm going to put the milliliters on top, and it's 0.9982 grams for every 1 milliliter. Okay, now look at your units. This is always the thing in chemistry. If your units are going away, you're going to be successful. So what units are left? Milliliters and water. What did we want from the very beginning? We wanted right there, we wanted milliliters and we wanted water. Okay, so it is a really long problem, but it's about the hardest you can get. And so I kind of like to start with a really hard one, and then we kind of work to some easy ones. Now, the math. So get your calculator. How does the math work? You plug in the first number right here, and then you multiply if it's on top, divide if it's on bottom. So get your calculator out. Here we go. 775 multiplied by 0.7025. I'm going to hit enter. I'm not going to divide by 1 because it doesn't do anything. If you'd like to divide by 1, feel free. This is going to be on the bottom. So this is on the bottom, right? So now I'm going to divide. So now it's going to be divided by. So I got my answer, and I hit divided by in my calculator, 114.26. I hit enter. Now look, okay, I got something on top and something on bottom. So I'm going to multiply by 9. Sorry, I'm thinking, sorry. I'm going to multiply by 18, hit enter, and then divide by 2. It's the same as multiplying by 9, but that's the best way to do it. Multiply by 18, then divide by 2. This is on top, so I'm going to multiply by 18.02, hit enter, and then that's on the bottom, so I'm going to divide by 0.9982, and you do all of that work. You're like, man, that's a lot of work. And then look at how the answer turns out. 3 sig figs here. So our answer, we're going to want our answer to have 3 sig figs. So our final answer is going to be 774 milliliters of water. So we do all that work, and we end up there.